5.3 is quite long, but not quite difficult. Let's go ahead and take a look at it. A 5 kg box moves up an inclined plane AB at a constant velocity of 1.2 meters per second when a force F is applied. 5.1, let's calculate the magnitude of the force F if the power that is used to move the box up the incline AB is equals to 57.6 watts. So what is the information we have? We have the power. It is said to be equals to 57.6 watts. We are looking for the force. We have the average velocity, the constant velocity. I mean, we have V being equals to 1.2 meters per second. So how can we find the force with these three variables? You just need to recall that the power average is equals to the force multiplied by the average velocity. So what is the power? That is 57.6. What is the force? That's what we're interested in. Multiplied by the average velocity. In our case, it is constant. It is just 1.2. So that will be our average. We just need to divide both sides by 1.2. And if we do that, we get a force that is equals to 48 newtons. That is 5.1. Quite straightforward. Let's take a look at 5.2. 5.2, we're supposed to state the work energy theorem in words. The net work done on an object by a net force is equals to the object's change in kinetic energy. That is 5.2. 5.3, the box now slides down slope BC. If the coefficient of kinetic friction of slope BC in the diagram above is 0.25, calculate the velocity of the block at point C by using energy principles only. So if the question says using only energy principles, there's three formulas you can use. You can use work net, you can use work done by non-conservative forces, and then you can use the conservation of mechanical energy. Well, the only way you would use the conservation of mechanical energy is if the only force that is acting on the object is force of gravity. If that is not the case, we cannot use the conservation of mechanical energy. So now we're left with work net and work non-conservative. Let's write the information we have down and see which formulas we need to use. We have the coefficient of kinetic friction. It is 0.25. We have our angle theta, which is equals to 32 degrees. We have our height, which is equals to 1.6 meters. What else do we have? Obviously, from the height and our angle theta, we can find the length of our incline. We can easily see that sine of 32 is equals to the opposite, which is our height divided by our hypotenuse BC. So BC is just equals to 1.6 divided by sine of 32. Let's see if we can use work non-conservative. So this will be equals to the change in kinetic energy plus the change in potential energy. Which non-conservative force is acting on our object? It is frictional force. So the work done by friction will be equals to Fr multiplied by delta X multiplied by cos of 180. So what is Fr? Fr will be the coefficient, which is 0.25 multiplied by the normal force. The normal force on an incline is mg cos of theta. So we're going to have 5 multiplied by 9.8 multiplied by cos of theta. Theta is 32. This is just the frictional force. Now we need the delta x. Delta x, as we have calculated above, it is 1.6 divided by sine of 32. Then everything multiplied by cos of 180. This will be equals to minus 31.3666. That is the work done by the frictional force. If we substitute it back into our equation, we're going to get minus 31.3666 being equals to the change in kinetic energy. So that will be a half. The mass is 5 kgs multiplied by Vf squared minus a half. The mass is 5 kgs multiplied by Vi squared. Our object was moving at a constant velocity of 1.2 meters per second. Potential energy final will be the mass 5 kgs multiplied by 9.8 multiplied by the height final at point C. That will be 0. The initial potential energy. The mass is 5 multiplied by 9.8 and then the initial height is 1.6. So minus 31.3666 will be equals to 5 divided by 2 Vf squared. So now we just need to add this term with this term. This will give us 0. If we do that, we're going to get minus 78.4. It is obvious what we need to do at this point. We need to take minus 78.4 to the left hand side. We're going to have 47.0334 being equals to 5 divided by 2 Vf squared. So Vf will be equals to the square root of 47.0334 divided by 5 divided by 2. Everything to the power a half. It's equals to 4.34 meters per second